part is, okay, it's cool. Yeah, the hard part is just really knowing where this all comes from and all of that. Yeah. Okay, so we are continuing, right? So again, it's saying opinion has 30 drives, opinion 30 teeth. In this case, they're telling us drives a gear which has 80 teeth. Again, in keeping with Mr. Kiefer, and he's definitely correct. The so-called wheel has more teeth. The profile of the gear is involute, it's always going to be with a pressure angle of 20 degrees. You've got a module and you've got a 10mm addendum. Find the length of path of contact, the arc of contact which we've done, and the contact. Key thing. Again, what I'm going to say to you, you will notice in the next problem, you always have to find at least the path of contact, or the arc of contact or the contact ratio. And then there's always these extension parts. So if you can at least do the first part, you've got bulk of the marks. Is that clear to everyone? Does it make sense? What I mean by that. So the core part of the question always remains the same, but then towards the end, it's always this extra information. Is it clear? Okay, I hope you guys got that. Yeah, thanks, Bradley. I'll work through this one. So again, obviously we copy our formula sheet. The only thing you have to do is probably the gearing, the gearing formula. And yeah, so I'm obviously just thank God for online. You can show things with ease. But same old, same old. First step, as per normal, we work out our pitch circle radius, small r, and that's just going to be the module, small t over 2. The module in this case is given as 12. The pinion has 30 teeth, and we're dividing by 2. Right? Wanting to show you it's the same procedure. Please walk with me through this one. It's always the same. 180 millimeters, right? Obviously, it's a small one. The big one, it's small m, big T divided by 2, and our module is 12 times 80, then divided by 2. Okay, and we find our pitch circle radius is equal to 480 millimeters, right? Our pitch circle radius. So that. I'm sure you guys don't need a second to think about that. It's quite straightforward. Pulling, are you happy, Mr. Mart? Good afternoon. Okay, no one's saying anything. Thank you. Next step, guys. Pulling, what is the next step? Please tell me. After we find our pitch circle radius, what is the obvious next step? I'm deliberately asking everyone.
Find our
thank you, Mr.
RA addendum.
Yes, our addendums. That's it. Same old. You'll see. RA is going to be 10 moles given to us. So we say, oh, that's big RA. So let me start with the big one. So it's 480 plus 10. I can do this. That's for 90 millimeters. You get a 1 mark for that. You find a small RA, and that's going to be, what's it kind of easy now? 180 plus 10, right? The 10 is typically always the same. So that's 190. And then again, 1 mark. Yes. Silas. Wait for Silas to gather himself quickly. Okay, I'll continue until he mentions. So guys, again, Silas, you can speak.
No, I thought I put the mic on. No, I thought last time we used, like in this case, we're supposed to use 12. Why 10?
It's given you a 10 millimeter addendum.
Last time the addendum was the same as module. Now it's different.
No, don't worry. I didn't mention to. So can you see they say each rule has a standard addendum of 1 module? Do you understand it? It's telling you. In this case, 1 module was 4.5. Are you with me? If it says 2 modules, then it'll be something else.
Okay.
So they'll tell you. So I'm saying typically they'll give you the module. They'll tell you it's 1 module or 2 modules, but they'll give you the value. It's not like it's a vague value, if it makes sense.
Okay, I get it, sir. Thanks.
I'm gonna show another example. It's good that we're talking about that because obviously it's something you got, and I like that. I'm gonna go to example 12.4, all right, which is something similar to what we did, and I'm gonna show you what they say there, Silas and Mr. Matoso. So they say there, assuming an addendum as a standard and equal to 1 module. You see there, which means it's 5. The addendum is 5 more. Are you guys happy with that? So they'll tell you, man. They might give you, it's typically, it says it's 1 module or whatever, 1.5 module or whatever, but in this case, it's just giving it to us as 10 module millimeters. Are you guys happy with that? Is everyone happy with that? If there is unclarity, please ask. Yeah, thank you, Silas. Thank you. Okay, so I'm just making you aware it's typically a module value, but it can be a straight value. Like in just say, yeah, it's easy for you. So guys, as per normal, we want to work out KL, which is our path, and KL will be equal to KP, path of, thank you, KP, which is a path of approach, plus KL, which is a path of recess, right? And so typically I said your the standard is always using the big one, so we know it's going to be, and I don't want to really write this over and over, but it's going to be your big RA squared. So I'll just actually write it in here. What is KP? We all know what KP is, obviously there. So your big addendum for 90 squared. Let's please work through together. I'll calculate it myself. So I know it's 490 squared minus 480. Luckily, we'll have to work in millimeters, so that's nice. That's squared cos pressure angle squared, and obviously minus outside that bracket we have big R, which is 480 times sine 20. Okay, so again I'm showing you it's the same story every time, same thing, times cos 20 squared outside the bracket, my minus times sine 20. I didn't have the sine 20 here, and I'm not sure my answer. You should get 27.76 or 77 if you want. Yeah, just call it 78. Yeah, millimeters. Is it clear to everyone? Yeah, thank you, Ms. Matoso. Then we walk up. What's the next step as normal? Your path of recess, KL. Same old, same old. 1, 3, 2 marks here. 1, 2 marks. That's 1, 2, 3, 4, 5, 6. It's gonna be 7, 8 marks now. Watch this. Easy. So I'm gonna keep my same formula. All I do within my calculator, I just change my values now. So I'm what is RA? RA is 190. Then I have 180. I keep my same values in my calculator, so I don't have to type in again. And then 480 again, so it's big, so it's going to be 180, and it's going to be sine whatever. Yeah. And if we get your path of recess, I get 24.98. Told you guys, it's you're going to see more and more as I do them, like, oh, it's the same, it's all the same. Therefore, your path of contact, it's a straight sum, no complex numbers. We get 52.26 millimeters. And obviously for this, you either get a mark or 2 marks, depending on how I allocate the marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At least 10 marks, guys. It's not difficult. Thank you. I don't get 982. You're out. Am I wrong? That should be 24.9. Oh, it is right. So you're 982. Oh, I don't know what I got there. Anyway, yeah, maybe I made a mistake. So that's the same. And now they want to work out the arc of contact, right? So the reason why we want to work out the arc of contact is because we need the arc of contact to find the contact ratio, which is the number of pairs of teeth in contact. So you have to find the one without the other one, right? So the length arc of contact is equal to your path of contact over that over cos 20. Let's just quickly do that. And you get 55.62. That's what I get. You guys get that? Yep. Fantastic, right? After that, the contact ratio is A over C over PC, right? And what is that PC? You guys remember? We didn't actually touch on that PC, eh? We'll talk about it now. So we have an arc of contact, and PC is that circular pitch, right? And it's very simple to work out. All we have to do is take pi times your module. That's your circular pitch. So in this case, it's going to be pi times 12 gives you 37.699 millimeters. Always remember it's pi m. That's your circular pitch. If you're wondering what it is again, I'll just quickly show you. Where is it? Circular pitch. I mentioned to you. There's just think you're working out. There you go. Circular pitch. You see there? From that one tooth to the other tooth. Obviously, we need this kind of thing to see how much stuff is in contact. Of contact 55.62. You simply divide by that value, or the 37.699. You can just quickly do that. And we get an answer of 1.47, right? Wow, welcome to the end of S4. You've made it. Not cool. So this guy, I'll probably say 1 mark here. 1 mark here. 1 mark here, and definitely 2 marks over here. Are you guys happy with this process? Any questions? Nice, eh? Yep. And if I'm going to be fancy, I'll ask you 2 things maybe, right? That's if I'm going to be fancy. Obviously, we want a contact ratio, like I said, greater than 1, particularly 1. I might ask you a basic question. Would you recommend using this gear? Explain the contact ratio. What this means is that there's one pair of teeth in contact with the other teeth like 47%. So that's just some extra stuff. So anyway, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 marks. 14, 15 marks. I might give them extra marks somewhere. Right? So I'm not going to do this process for the next problem again, but I'm just showing you it's the same. Make sure you understand this first part. Okay, is there any questions before we move on? Any questions, students? Please ask now. You don't understand the formula, you don't understand, where we got what. I think anything will be worth, any question now is really important. So I'm gonna, like I said, I'll talk to the first guys. Any questions before we move on? Are you behind? Tell me if you want to catch up. We still have time. Please Make sure you know this process. It's I promise you, it's really, it's, I don't know why people didn't do it last year. This forward. But yeah, I must be careful. I'm gonna talk through the other one, and then I'm gonna do the part that I actually want to do. Yeah. So obviously we good to have a textbook, because I won't be solving stuff. Okay, guys, can I have at least 4-5 thumbs up before I move on, so we can get this ball rolling? Thank you, Jason. That's one. Yep, one more. Easy, guys. It's not difficult. Explaining one more, guys, please. Thank you very much, Mr. Kiefer. Okay, so the question I'm talking about now is this one. That's example in the textbook. Obviously, you know how to solve it. The new part, which I am referring, right? When I say new, that's debatable. But it's this section which states this. So I don't need to read the whole question, unless you want me to. But over here, from here to here, so I'll read it. Determine the velocity of sliding between the gear teeth faces at the point of engagement, at the pitch point, at the point of disengagement if the smaller gear is the driver, right? All the other stuff is extra information. And then the second part of the question I want to talk about is also find the angle through which the pinion turns while the pairs are, while any of the pairs are in contact. So that's two parts of the question, right? So what do we mean by the point of engagement, at the pitch point, and at the point of disengagement? Do you guys remember the showed you of this? Right? I have another nicer diagram. I'm deliberately using the more crude one here, which I explain, just to see if I explain well or not. Testing, presenting some self-reflection. Where is this guy? I use that. Maybe that one. Maybe this one. Yeah. Okay. So can we see this guy over here? Right? It's just make him big, duplicate him, and then yeah. So we got two gears touching. So we all know that P is a pitch point, right? Are we all happy with that? And then next is we have to, so M, so if you look at this diagram over here, right? So MN is a path of approach. PN would be a path of it'll be the length of the path of contact, right? So what I'll make you aware, so you obviously can't see the gears now, right? But point M is where it first engages. At P would also have some engagement, and then it eventually departs at N. So talking to that particular slide which I was referring to is this one. And if you look at the slide, it says the first point of contact is A. Obviously, it looks different now. In this case, our pinions on the top, right? At A, with the flank touches the tip of the gear, right? You can see there. Then the last point of contact at the end on this side, where the last point of contact is where the tip touches the flank of the gear now. So I'm making you aware that what this really relates to is that when we find our velocities now, back to the previous question, we have to use our path of approach to find the first sliding velocity, and the path of recess to find the other. You know the different ones, man. The first point of engagement, you'll see what I mean. So we have to use those KP, KL. This is a very test level like question. Very on that level of being, we could have been assessed on this level. Okay, so how do we solve it? Pulling, same old. So like I said, I thought the first thing they obviously do is find the velocity ratios. Obviously, we can do it at a later stage, but we know how they use it. Omega 1 over omega 2, and that equals basically your T over big T. Or they have it, yeah, they obviously flipped it around. Big T over small t. But then again, look how they start. They find the pitch circle radius of the smaller gear. They find the pitch circle radius of the larger gear. They find the radius, the addendum of the smaller one, and they find the bigger of the smaller one. Obviously, what's important here is from there we know where we go. We talk about the points of engagement now. Then they find the path of what's K of approach. They find the path of recess, and then obviously that's where we're gonna and obviously we can find the path of contact, basically, which is the next step of the actual problem. But now what we are looking at is the what is this, the velocity of sliding at each one. Okay, so let's quickly do that. So that's what I said. You can see the procedure is essentially the same. So I'm just going to have it here first. So my KP is going to be 12.65 millimeters. So that's path of approach, path of that, path of approach, sorry, path of recess. This was 11.5. Okay. So for us to find at the point of engagement, so your sliding velocity, so it's sliding velocity at, so what they refer to here, sorry, is that they use, we know the distance at the point of engagement is K from the pitch point P, or the length of the path, and this engagement basically it's K. So it's a very simple thing we basically do, is that we use V KP omega 1 plus omega 2. It's like it's basically the rubbing velocity at different parts, and then it's times by KP. So I'm going to put my omega 1 here and omega 2 here, so you guys can basically just work it out from here. But guys, do you understand what I mean by the procedure is the same? Are we all happy with that? Are we all comfortable with finding, the pitch circle radius? It's the same, the addendum, and then you end up with the same stuff. Are you guys content with this? Okay, LPL. Okay, yeah, you mentioned it there. Are we all on the same page? Are you guys lost? Please tell me if you're lost. I'll recap. Silas, you got a question? I see your mic is on or something. Ivan, Mr. Wormerans, Mr. Kuzo, Mr. Trele, if you are, yeah, you are here. Bradley, any questions? Not this time. You guys, my point is just basically, the first point is understanding where the point of this engagement is, disengagement, and we talk about the pitch point. And also the second point is it's the same procedure. No need for us to now repeat all the calculations, whatever. Okay, so where we move on to now is obviously finding the first part. So this is at engagement. So always remember, engagement is in the path of approach. It's kind of obvious. It engages there. So to find that, all we just take is 209.5 plus 1047.75, and our KP, which we found, we just times by that. 12.65, right? We can have the millimeters if we want. You guys can quickly do this as well. Straightforward points, guys. And you'll get 375 millimeters per second, right? At engagement, right? So I'm going to call it PL. That's on the path of recess. Obviously, recess, as it says, still 209.5 plus 104.75. And we times it by PL, which is what? 11.5. I really hope I did this section justice, I know I missed a few things, but yeah, I mean, I think I'm trying to just accentuate that it's not difficult, And obviously, what we tend to find that is we lose a bit of speed there. 875 millimeters, yeah. Are we all happy with that? of disengagement, right? Is this a lot of information to take in?
This chapter looks good.
Mr. Matoso, it's really good. I'm telling you now. That's I don't know what more to say. Like the way I'm trying to explain this to show you that it's not. If you have the first part down, it's really just you just kind of move with it. You know, it's really it's easy, really. And then is there any question with the engagement and disengagement before I move on to the pitch point? Thank you, guys. So that's how we don't have to just repeat, but obviously once you must score the extra. Let's see the extra marks, right? So I'm gonna paste this here. It's kind of obvious. So starting with this question here, just to show you the mark allocation again. Like I said, this is a very good question. Here we get. I'll probably not give you a mark for that. You probably get 1 mark here, 1, 1, 1, 1. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Obviously, the path of we know the it's 10, 11. The length, the full length of content. So this should definitely be could be 12, 13, 14, 15. This could be 2 marks here. So I'll say 16, 17 maybe. And then for this, at the pitch point, for 2 marks, make sure you get this, is that the velocity of sliding is proportional to the distance or the point of contact from the pitch point, and there's no velocity basically there. There's basically there's no radius if you want to think about it. So if I show you on this diagram over here again, page that thunder. Sorry about that. Over here. Okay. We're nearly there, guys. Just bear with me. Yeah. At that point P, there's no velocity happening there. That's a stationary point. That's why it's a very important point. 2 marks, right? So be aware of that. So that's our 20 odd mark question. But now we're not done yet. And the next part of the question was to work out, if you remember, also find the angle through which the pinion turns while the certain venues created. Also find the angle through which the pinion turns or any pairs of teeth in contact. Actually, when you're hearing this, what must come to obviously mind is your arc of contact and your contact ratio probably. So let me just write again our KP. So again, this is another extra part of the question. And just get the right color for you. KP is equal to obviously that we've worked this out in yeah, you know what I mean, and we know PL equal to 11.5, and obviously K the sum of the two, right? And which will give us an answer of, what's the answer I'm looking for? 24.15. Okay. So to find the angle in which the pinion has turned, right? So be aware they can ask you the wheel, or they can ask you the pinion. But obviously, if you know the kind of the procedure of it, it's fairly simple. So I'll throw it for you. This is from your formula sheet. There's that, and also here's another one. The length of contact. So all you need to really do is fairly simple. You find the length of arc of contact, which is easy. You find the angle which the pinion is turned. To find that, you say the length of arc of contact times 360 divided by the circumference of the pinion. And of course, circumference we're talking about there is going to be the pitch circle radius, right? So I'll just quickly do it. Obviously, I'm just putting the formulas up there to show you it's in your formula sheet. So it doesn't come from, it's the same stuff you just actually worked out. But the reason why you're working it out is to find these just give me a moment. So let's see something. I just gotta really put an email. Okay, thank you. So yeah, let's work out our length of our arc of contact. So that's going to be AOC. We've got KL to be 24.15 cos of 20, right? And we get 699. All right. So if you want to work at the angle, turn by pinion, can we say pinion or let me just call it theta pinion. Okay, maybe it's a bit messy now. Yeah, so I'll probably just duplicate. Just take that all away. All we have to do now is just say so theta pinion. Obviously we know what this is. It's 25.7 times 360 divided by 2 pi times the pitch circle radius, and obviously that was worked out over here, 50 millimeters, right? So again, it's basically what this is basically that kind of thing. But obviously it's not being shown to you, so obviously if you do that, you should get an answer of 24.45 degrees. I'd like to ask you guys, can you find the angle turned by the wheel now? Could you please kindly do that for me?
Sir, I didn't get the 50.
Yes. The 50 where?
2 pi 50.
2 pi 50. You're asking me where I get it from?
Yeah.
So it's the circumference of the pinion. You could have said pi times d as well.
Okay.
Yeah, what I'm saying is basically using this, right? So it's an arc. Remember what this formula does? Remember radian measure? That's the arc of contact now we have, and now what we're actually seeing is as it rotates, how for that particular instant, how much. Obviously, the reason why the 360 and pi is there is to rotate it into degrees now. So that's what it is. So that's your arc of contact, and obviously you well, sorry, it's your arc. So that's your arc, and then anyway. So can I quickly get my wheel? So the still be 25.7 times 360. But what is at the bottom? 2 pi times. You tell me, just give me the 2 pi times what? The wheel.
100.
100, yep, straightforward. And if you go back to that one, times that by 100, you get an answer of 14.75 degrees. So what it means is that also find the angle through the pinion which turns while in the pair. So yeah, you can find for the wheel and the pinion. I'm just making way. And again, this is straight another 2 marks. This is like a 25 mark type question. So it's just really getting to know, or if you have to work at both, depending. Yeah, it's just getting to know. But what is key is to know this is very common engagement. This engagement you'll see At the pitch point, it's going to be 0. And obviously, yeah, this is another question from the thing, and they want basically the same stuff here. This at the internet engagement commences, when engagement terminates, it's disengagement, and at the pitch point. And here they just give the pitch line velocity, so they give you velocity already. I hope it's all clear. I hope you guys got, you know, the concept of this. We're basically at the end now, or close to the end. Any questions, guys? Should I repeat something, or you lost? Yes, thank you.
So you lost me towards the end. Why did you times it by 100 instead of 50?
No, so I was demonstrating for the pinion. If they ask the pinion, this is what you do, right? 2 pi times 50. 50 is the pinion's radius, and where the pinion,
Okay.
the pitch
So
of
you
the
were
radius.
doing
And this
it
one is
for
for the
the wheel.
yes.
Okay, I see.
That's basically all. Nothing more than that.
Thanks.
Yeah. Anyone else? Town is crazy, man. It was like hot and how's it? I don't know if you guys have rain and thunder on your side. Yeah. But it's crazy. Guys, can we move on? We're nearly there, guys. We're 70% to 75% there. Thank you, Mr. Kiefer. So I'm just showing you the variations. Obviously, you've done the first procedure. That is easy. Okay. We're doing good for time, obviously, because yeah, it helps you guys a bit sharper. Guys, this is the second concept, and it's not a difficult concept. Thank you, Mr. Matoso, to understand. So there's something called interference in gears, right? And it's a fairly basic thing what happens if you don't design your gear. Sometimes, I mean, I'm sure BMW, all these people who make these sophisticated engines, they spend a lot of time in the transmission systems. I mean, even if you try to build a transmission system from scratch, which is highly impossible, normally you can buy these gears off the shelf. But even if you are doing that, one has to obviously check. You pay for that quality, right? But nevertheless, they say contacts of portions of tooth probes that are not conjugate are called interference. I'll unpack that better. But it says basically where occurs when the contact occurs below the base circle, right? And what it means is that if one tooth is going to another base circle, right? So in this case, the driven gear to the driving gear, you're going to find some interference. And what happens is it kind of chips away at the tooth. I don't know. Basically, it's not meshing correctly. I hope you all get that, but I'll elaborate further. So another case is there. You can basically see a nice, more simple example is that you can see the one tooth is inside the base circle. And what they particularly call that is that there is the involute portion of the thing, which is basically just below. And if the involute and the volute portion, or the involute and it's not involute, but anyway, and if it's like basically in this base in the base circle, we get something called interference. And it says if it does that, if it's not properly done, big material removal, you'll see on your gear slowly being chipped away. There's a bit of wear. That's why you're finding those sliding velocities, kind of, and yeah, and high noise. It don't sound nice. Obviously, it's something which can happen with gears. It's a thing when it arises if you don't design your gears properly. So just interference, right? It's not something we want. And the point of where we're really heading to is that we need to find a way so that how do we actually find a way to make sure that we don't get interference with gears, right? What the explanation basically is here, what they're explaining in this thing is they're giving you gear and the pinion and the wheel, and they basically explain the same thing where they're saying if you look at a little constellation will show that if the radius of the addendum circle, let's just keep it there. So if you look at the radius of the addendum circle to O1N, which is O1 is the pinion side to N, so that's the addendum circle, right? If we increase that to a point, the contact L, which will be inside of the base of the circle, and which they say, and not on the involute profile of the tooth. Obviously, the involute profile, the one where they're nicely meshing. And if we do that, we're going to get interference. So the basis, so the key word here is addendum. So if we increase the addendum, then we're going to get some interference, right? And the base is the phenomenon with the tip of the tooth undercuts the root of its mating gear is known as interference. It's just the same thing I'm mentioning the whole time for a particular reason. So why is it important? So they say a similar thing could have been done is when you increase on the wheel side, right? It's O to M. It's that stipple orange line. We increase into the other portion, and then what also tends to happen there, you always interference. But what they say, what's important is saying the limiting value of the radius circle of the pinion is O1N and O2N. So that's the limiting radius. So anyway, so they say from the above discussion, we conclude that the interference may only be avoided through if the point of contact between the two teeth is always in the involute profiles, right? So not below the base circle, but essentially above. And so in other words, interference may only be prevented if the addendums of the two circles or the two mating gears cut the common tangent point or the base circles between the point of tangent, which is essentially that point P kind of thing. So they're using the addendum. We could have used the D addendum as well, but obviously the addendum is like the highest point in the actual of each gate. And there's basically heads of two. I'll get into now. And there's not only this way of, like I said, it's not the only way to avoid interference. I won't be asking you this, but we can move obviously cross hatch tips of the tooth. So obviously, remember the addendum is to the tip of the tooth. So if it's a hatch tip, we cut it off so you get it right. So that can happen. Obviously, reduce addendum, which we've been talking about the whole time. So that's one of the main things, obviously, to reduce the addendum. Also, what we can also do is increase the number of teeth on the mating pinion. So that's very interesting as well, right? We increase the pressure angle, right? That's another thing. We can also look at tooth profile modification or profile shifting. And also another one is to increase the center distances, right? So that's a very interesting. So if you increase the center distance, you actually, obviously, if you think about it, you have two gears next to each other and they're not mating properly. And if you kind of push them away a bit, you might find that they will mesh a bit better. I think it's kind of self-explanatory. I'll show you, it's not in this particular figure, but I'm making way. But the main one, which the book has adopted, is using the addendum. And again, I'm going to say interference will be prevented if the addendum circles of the cut the common tangent to the base circles between the 2 points of the tangent. You'll see it when you actually have a proper look at it. Anyway, based on that, what they have developed is the maximum length of path of approach, and the maximum path of recess, right? So, and then basically the end of it, you're gonna find that your in the case of a addendum, a pinion, and a wheel, is that the path of approach and the path of recess is basically half their possible value. So you base all what you're doing to find the maximum length of contact, which is the absolute maximum. You have to half basically the length of recess and approach. Add them up, you get a new value over there, right? But this is not particularly important. What is important is this part. So based on the previous part, for especially the design end, what we're really looking at here is when we have a particular gear, we want to limit certain things, and what it is here, we're looking at two things. We have to minimize the number of teeth, right, on the pinion to avoid interference, and we can do it on the wheel. So what they said in the previous article out avoid interference, the addendum circles for two mating gears must cut on tangent to the base circles between the points of tangency. The limiting condition will reach when the addendum circle the pinion will pass to these points M and M, right? So it's just again the same thing. There is a common tangent that point P I was talking about. So there are two quick ways to do it, but I'm not going to show you the two quick ways. What you're supposed to know, according to your textbook, is this. So all you set with is two extra formulas. Is it two extra formulas or 3 or 4 extra formulas? And what the formulas basically do for you it uses the section before, and what basically happens is, to avoid interference, we basically have to limit the amount of teeth on the pinion, and also to limit the amount of teeth on the wheel. So if you look at this formula here, it gives you the addendum. Remember, we talked about addendum, so that is at maximum addendum, right? For pinion, which is going to be T over 2 root 1 plus big T over small t, and obviously it has different variations. Stop here. So essentially, if you look at it there, it's telling you what the addendum pinion is. It's O1N minus OP, which obviously we don't need to have a look at. And O1P is basically your pitch circle radius, if you remember the P from the center going up. And the formulas are in your formula sheet. And I also simplified it. If you want to find the number of teeth straight away, obviously they will rearrange it so you can find the number of teeth straight away, right? This is the addendum of the pinion. So the same thing, again, if you have equal gear ratios, there's like a quick, a quick thing there, but that doesn't tend to happen. Furthermore, they're giving you different angles. And they say if you have a 20-degree stop involute, for instance, or full depth involute, your number of teeth will put in about basically there's limitation. A lot of teeth. There's a whole science or mathematical basis on why for the standard profiles. Same for the pinion, you find for the wheel. And the wheel, you have similar formulas, and you can see over there T, it's M times big T over 2. It looks exactly the same as the pinion one, but they just flipped a few things. So obviously just showing you your formula to be comfortable, to show you what it exactly looks like. Let's just get the formula sheet here. Yeah, I've pasted it at the end. It's self-explanatory. And guys, this is the more, I wouldn't say advanced stuff, but the first half of the section is the final exam. But if you get into the reassessment addendum in a reassessment base circle, you're probably gonna have to know a bit more about gears, obviously. So yeah, so the previous stuff you've done is more for the FISA. Yeah, assessment territory, I would say. So what I'm doing here, I've just pasted the formulas for both addendum of the wheel and then the maximum minimum amount of, basically the maximum addendum, which results in a minimum amount of teeth. I did the same for the pinion. Obviously, see the formulas look nearly the same. It's for this one. If you look at this one, here we have big T over 2 with, and then it's the same on this side here, but the only difference is that they flipped around. Here we have small t and they flipped around big T over here. I don't know if you guys can see that. These are the two formulas I particularly look at. Can you guys see that? Did I lose you a bit there? Okay, thank you, Mr. Van Tambo. So yeah, it's the same thing. It's not difficult, it seems, but once you start the question, I will, obviously it's going to be a bit better for you. But the point is, obviously we don't want interference. It's efficient the transmission system and makes vibration, it makes a lot of noise. So it's just this is just a method to show you that, okay, you're only allowed a certain amount of teeth, or this is the maximum amount of addendum, because if you go past that, you're gonna encroach on the base circle of the other gear, and obviously it's not gonna vibe liquor, and obviously we don't want that. So those formulas are all on the formula sheet. So now we're heading to the end. So there are two small examples, which I'm not probably gonna do now. Don't think it's worth doing, but it's basically applying those formulas over here. All right. But what I do want to show you is these three examples, which I highly recommend you work through: 12.11, 12.12, and 12.13. I highly recommend you work through those. So those are the small ones. It's not really a big deal to work through that. but these are all the more so-called more advanced. I can't see them in the formula sheet. Maybe we have a different formula sheet. Didn't I upload? I think I re-uploaded just have a look. I'm not sure if I updated the formula sheet there. But I added afterwards. Let me just quickly see. So yeah, it's just like the extra bit of content. And I'll show you how it all starts. Formula sheet. Yeah, I'll check now. Don't know why it's not opening on my end. Yeah. So I need to update. I'll remove it. So I have to put in the new one. But you will get those formulas, right? That has to do with interference. Okay. Thank you, Silas, for checking it out for us. So you might think, oh no, this is a whole new concept. You know, what now? Where do I begin and all of this? But guess what? It's all the same. The only thing new is this part. So I'll read you the question, then I'll solve it, and we'll solve the last part together basically. So what's new here, right? Is just simply this, and the keyword is obvious. Mastering. Let's see. I open this guy up. Here you are. And when you know to use interference, so let's read. A pair of invalid spur gears with a 16-degree different pressure angle has a pitch of module of 6 millimeters in mesh. That's key. The number of teeth in the pinion is 16 and its rotational speed is 240. When the gear ratio is 1.75, find in order that the interference is just avoided. So when you see this, you know you must use those formulas. And all the questions really do is you need to use those models which I mentioned. So now, typically, how did we start the question? We start the question with the radiuses and all of that. All we need to do now is find the addendum, basically, of the pinion and the gear wheel. And once we have that, right. So let's quickly try this out. So I think we'll call this our last question for the day. Yeah, everything else should be straightforward from me. I don't think there is no other. What I'm doing now is the novel part of it, right? So to find, first thing, let's find the addendum on the wheel, the big one first, right? For the house. We've got a formula, the M over T over 1 plus small t over big T, bracket small t, plus 2 squared is it minus 1 separate, right? So sine squared theta, and then minus 1 over there. Okay, the give out module 6, and then obviously now they say what do they say there? Do we have the pinion's teeth? So how do we find so we have 16 teeth. How much teeth do we have on the what you call it, on the wheel, if I'm correct?
28.
Yes, go for it.
I said 28.
28. Why is it 28? Thank you. So it's 16 times 1.75, right? Times the gear ratio. It's just is it big T over small t, something like that. G, right? Which is also equal to omega 1 over omega 2, which is also equal to big D over small d. Sorry, I'll call it T1. You get the idea, right? So that's 28. 1 plus small t 16 over 16 over 28, I think. Yep. Repeat the same thing again. 16 over 28 plus Where are we here? Sine squared 16, 1. Okay. So obviously the smart way probably is to work out the bracket first and then times everything else in. So I'm going to quickly do that. So guys, this here is a new part. So I recommend you try and get comfortable with this. This is it. So when they talk about interference, 100% these formulas are going to come up. If you don't hear interference, that is not your problem. That is not your problem. So I'm just making, and I get 0.05434 inside the bracket. Now just simply times by this over here. So this is our addendum now. So we have our addendum. Remember, normally they told us, they gave us a addendum of 1 module or 10 millimeters. In this case, we have to work out the addendum for these type of questions. So I got an answer of 4.56456 millimeters. Do you guys agree? So that's my addendum of the wheel. You guys happy with that? Start to just, I don't know if you're with me. So what I want now, you have to find the addendum of the, what is this called now, of the pinion. So you have to use that formula. So it's exactly the same. You can also have module times small t. It's exactly the same formula basically. There's no difference between the two formulas at all. Just you're flipping things around. So can we quickly get this? Can you please just try and do it? I hope you all understand the concept of what we're doing here. So I'll just write it out maybe. That's 16 over 2, or 16 times a module times 6. It's exactly the same. Big bracket, big root, 1 plus now 28 over 16. Close the bracket, 28 over 16 plus 2. Nothing difficult, just more content to study really. And of course, minus 1. And if you do that, you should get your addendum of your pinion. So just quickly do that. So I'm just making you go, when you hear interference, you know where to go to. These are the four. And when you have to find them, you have to find the addendum. That's the only difference. Normally they give you the addendum. For this interference questions, you have to find the addendum. So we have to find the addendum for the wheel and for the pinion. Let's quickly do that. Are you guys working out that addendum of the pinion? Guys, this is the last one. I'll show you now where it all ends. So Tamo, minus Silas, can just quickly work it out with my torso. 10 point, is that correct? I think it might be correct. 10.7, 10.748. Yep, that's definitely within the range. 10.748 millimeters. So now pulling, all we have to do, reverting back to the question. Now just start. We can just find the same stuff as per normal, right? So what we do now, we find big R, and what is big R again? M times T over 2. What is the module? Sorry, it's big T. Now we follow exactly the same procedure, guys. It's all over. 6 times T. What is big T again? He was 28. Why is it 28? Is it more? Yeah, divided by 2. I'll work it out for you. 6 times 28 divided by 2. That's 84 millimeters. And then we do the same thing for small r again. What is small r again? M times t over 2. 6 times 16 divided by 2. Work that out quickly.
48.
48. Thank you. And what's the next step, guys? Once we have our addendum and we have our so now we need to find the addendum circle radius. Sorry, before I get the addendum circle radius RA will be 84 millimeters plus what, Silas? Plus what?
84 plus
4.5.
4.
Yep, thank you. Thank you. Straightforward. We add them up. 4.56, 456. You get 88.55 millimeters. For the other one, it's 48 plus 10. Can you see now addendum is not the same now for interference? Interesting, eh? Interesting. 48 plus 10.748, and we get 50. Is it 58? Is my radius right there? 48.
Yes,
sorry.
58.748.
Yeah, no, I think I'm flipping the two around here. This is my wheel. The addendum of the wheel must be. I see. I'm making a critical mistake here, guys. Why are they flipping it around? What am I doing wrong? Addendum of the wheel, addendum of the pinion. Something is strange here. Yeah, no, it's correct, but I'm looking what they did now. So I'm just trying to figure out something. So it seemed like they flipped this stuff around and out. Why is this? Just give me a moment. For the bigger circle, it's going to be 100 plus the larger gears plus 9. I don't know if they made a mistake with this stuff. But yeah, it's quite strange. And then obviously this will be now 48 plus 10.748 is 58.748. Yeah, so I'm not sure exactly. Let me just confirm.
But same.
Yes, go for it.
I thought that 10.748 we got it from that the way we use the big T, which I thought is gonna go to the big R there.
You thought it's going to go to the big or this one, but this is the addendum of the pinion. You see, that's why I'm like, so I'm just confirming something. Addendum of the pinion. I'm just looking at something in another. Because why? I'm looking at the book and it says there it works out. Unless I have my formulas the wrong way around. So let me just quickly see. AW is the wheel, which is big T over T. That's definitely right. That's wheel. T over T. Yeah. So I'm just trying to think. I'm thinking of the circle, but it should be straightforward. It isn't really a, it's not like a trick or something. I'm trying to figure out where my logic is out. Why? So for the smaller gear, just give me a moment. I'm looking at something else. Where is it now? I got 60. Yeah, it's supposed to be. It's right here. Unless there's a revelation here, and we need to think about it. For the 60 plus, yeah. I think, to be honest, I think they made a mistake. I don't think their things are right.
Yes, sir.
Yeah, they made a mistake, definitely.
Yeah.
I don't think they're right here because
I think so. If they didn't make mistake, we did make, like, the big R is the pinion and the small R is one of two.
Yeah, I get that. Yeah, but do you think so? If you look at another problem, it doesn't fall the same way. So if you look at it, I'm looking at example 12.12.
Sir?
Yes.
So I think where you made a mistake, you see you put AW is equal to, that is supposed to be the pinion, and the AP is supposed to be the wheel. I think so. You just
interesting.
mixed up that. You just labeled it wrong, sir. So
Are you sure?
see, that AW is the small t over the big T, and that is supposed to be the pinion.
This will be, yeah, 6 times.
That
But I
AW,
mean,
sir.
check this. Check
So
AW
I
here,
think
right?
you just labeled it wrong, sir. So now when you're going into the equation, you just mixing it up because you just labeled
So
it
okay,
wrong.
let's just do
Listen,
30. I don't know what value.
yeah, but the book was clear. They say like we are right. Like for the pinion, they got 4,6. Oh, 10, sorry. They got 10.
10, yeah.
Yeah, as we got 10 also. It means we are right.
Yeah, no,
only
I just think the book probably like there's something it's fishy to me, but I can show you why I'm like, you know, obviously let me just quickly show you at, yeah, but obviously it's just a simple adding thing here. There shouldn't be really a debate, but yeah, I guess no one told him that they're wrong. I'll show you another example. 12.12. Let's just quickly go to it. I'm just gonna snip for you so you can see. Okay, yeah. So it's, check this out. Check this out. The only thing, unless you have to the way around, and but I just sit down and figure it out. Obviously, yeah. Anyway, so this is another one. So here they find the smaller gear, right? Big T over T. Is Mr. Rahman is right? Big T over T. Yeah, no, that's correct. So that's pinion there, right? So it's right. So that's the denim of the pinion. That's correct. And if you have big T over there, that means it's the wheel. So that's 18.6. Do you see there? And 9. So when they find the addendum, they say, take R of the smaller gear, which was obviously given in this case, plus for the smaller gear, which is 18.6. Do you see there? Then the larger gear, which was 100, and they're plusing the 9. The guys with me. I think the book flipped it, man. The book made a mistake. I'm pretty sure that.
They made a mistake.
Yeah. I'm definitely sure. I will another book. I'm gonna go to the note, the extra note I posted. Let me just quickly go there, wherever it is now. Just give me a moment. It's good that this is actually happening because I didn't even see. I took it for granted that it was correct. Oh, yeah, got it just now. Okay. Give me a moment. So I hope you guys are still following me at least. Not in the I'm looking at the extra note I've given, and I'm looking for something similar. And yeah, that's the max length. Here's a number of teeth. Yes, and taking an yeah. So I found the example now. I'm just going to show you this engagement. Why is it not mentioning? Why did about telling me about the addendum? Which bothers me. Just give me a moment. Nearly there. What's the least amount of teeth which can be used? I'm just looking at the yeah, okay, here's one. Yeah, here's 6 on the pinion. Just give me a moment. Are they telling me it's 6? Yeah, the wheel, the wheel, the pinion is 6. Unless, I don't know, unless I'm missing something, but I highly doubt it. Yeah, I think the book made a mistake, eh? I don't see, unless I'm thinking about it wrong. Why would we add the other addendum? But I'm just making sure everything is right here. Yeah, I found one here, but this example looks the same. Where if I have 9, they have 100. Oh, addendum of the pinion is 88.4. Yeah, I'll show you now. I'll snip this one as well, just to show you as well. Yeah, I'm not particularly sure. You know why one needs to be obviously careful. Okay, show you here again as well. It's from the same note. Addendum of the wheel came out to 9 millimeters, right? That's the wheel, which is kind of similar to this. And then the addendum of the pinion of the smaller gear came out to 18.54, which is kind of similar to this. And if you look at the add, they take big R plus its own addendum, which is 9. They take the addendum of the small one, which is, can you see there? 60 plus the 18.45, which is the opinion. So yeah, I think the book might have flipped it around or something. Are we guys all happy? So we all correct. It's good to pick up these errors, you know, while
Yes, I'm happy, sir.
yeah.
There was a
Okay,
mistake.
so just build. Yeah. So unless maybe I've completely missed something, but anyway. So once we have the addendum, guys, it's a simple process. All we have to do is go back to our formulas for the path of approach, which is also called KP, and obviously that's going to be what is it, guy, again? Big RA squared minus big R squared cos squared. Same old procedure. So the only difference with these ones, you got to find the new what is this? The new path of recess, which is going to be PL. Find the addendum, then you apply. I don't know. You know, like I said, it's if someone can tell me eventually, but I don't know. Maybe I'm missing something. And that is small r sine theta. And obviously, you find the path of approach, you find the path of recess, and then in the end you find the path of contact, and you find the maximum velocity of sliding teeth will still be at Kp. And then it's all the same from there onwards again. Same old. I'm looking, is 12.5 I'm looking at. I'm just trying to figure out something at 12.5. Oh, we're doing 12.11. Oh, I'm at the back now. Okay, that's 12.12, 12.13. I just want to see something. Getting the principal sim plus 6. Okay, guys, you know what? It's the end. So there's nothing more after this. Is there any questions really after this? Yeah, I hope no one was like disturbingly lost. Yeah, but I'm just making way for the internet to find a new addendum. So yeah, we now. Okay, guys, any questions? We're getting over time here now. So yeah. Can we adjourn now? Any questions with this interference stuff? What you must know? So we can get to the end of the lecture, official end, obviously. I'm just looking through something else here just to make sure. Yes, Silas.
Yes, I see. I think in 12.12, I think they use the formula correctly there.
Yeah. I think they just flopped the two around. Man. They made a mistake by adding the wrong. So it doesn't make a big difference really, but yeah. But yeah, we'll see. We'll see. It wasn't stated there. Maybe yeah. It doesn't look like a problem really. But let me know if you pick something up. Okay. Mr. Mantambo.
Sir, my question is about Friday. Is there anything, like any tips or anything for Friday?
Yeah, I'll get to that now. I was going to say that is correct. Okay. Yeah, I don't know. It seems all good on this side in terms of the interference stuff here. I'll get to that now, Mr. Mutambo, towards the end. Guys, again, do all the examples. Go over them. It's straightforward, really. All they're asking is maximum sliding velocity. They're asking maximum sliding velocity. They're asking, you know, all the usual stuff. Contact ratio. It's just for the first question. If you have a look at it, all they're asking you to find the addendum. So yeah, I will obviously re-look at it again and let you know if there's anything different. But like I said, I'm surprised that why would you like Anyway, so I think we're on the right track. Yeah, guys, it's at the end. If there are any problems, probably the class report probably inform me, but it shouldn't be really. It's not that difficult. I might post another chapter from another book if I can find, just to make sure that it's yeah. But we basically at the end. Well done. I don't think I'll be doing any of hardcore lectures. If I will do a lecture, it'll probably be asynchronous. I might, but I don't know. I'll see. It depends. But yeah, don't have to be attending class anymore. You can just focus on preparing. But the last thing what I actually want to touch was on before I get to test 2, right? Oh, let me talk about test 2 now. Test 2, there will be 3 questions. Definitely 3 questions. One question is any energy systems, multi-cylinder, mass of the flywheel, thickness of the flywheel, breadth of the, done that stuff, anything in that domain. The other 2 questions, which is on the inertia, forces and reciprocating parts, you have to look at, there's a few things to look at, that's the thing. So I'm looking at the chapter now, let me just look at it. You must know vertical, expansion and compression. I've touched on that, how the forces react. You have to make sure you know all the types of forces within the crank rod system, FP, FQ, FB, all of those guys. Again, double acting. Make sure you know double acting, how to find the net pressure across horizontal, vertical. The engine speed, which the values become 0, the turning moment on the crankshaft. You have to know, obviously, also, how to find the velocity of the piston, the acceleration of the piston. When the acceleration is 0 acceleration, what are the angles? Angular velocity in the connecting rod, the angular acceleration in the connecting. So the way you must think about the test is question 3 is kind of obvious. Question 1 and 2. Question 1 might be a bit easier, so you guys can score marks as per normal. You know how I am. The second question will be a bit fun. I'll play around with a few things. I'll test your understanding. Question 1 will be maybe straightforward, obviously, if you know you're studying, And then question 3 will be a multi-cylinder thing. I said it could be hard, it could be easy, it could be in between. Yeah. But make sure you know all your forces in the crank pin, your forces in the connecting rod, all the forces. Know them. You have 2 notes to practice from, which should be more than adequate. Vertical, expansion, compression, you know what I'm talking about. So Matambo, are you that? Anything else besides that? Did I answer your question? Yeah, thank you. So you get the idea. I'm not putting in the connecting rod. I'm not asking to find the dynamic forces and the correction couple. We're not cover, so we're not doing that. Like for the final, obviously you cover everything, and yeah. So guys, I'll see you on Friday. Obviously, it's probably be a long time since I see you since all the exams, but thank you, Mr. Mark. This special lecture, I'll probably just